think there's some great reasons to use it. There's sometimes when you can't use it. And the big one for me is if you're using Google App Engine standard environment, that does not support gRPC. And so I'm going to talk about how we can avoid some of the ugly code that you can see when you have to do marshalling and unmarshalling all the time, and all that repetition. I'm going to chat about that today. So this is me. I do computer things, and I like to contribute to open source where I can. And if anyone is interested in joining any of the projects, let me know. It's always looking for more maintainers and contributors. It's awesome. Does anyone, can you show of hands, has anybody created a gopher on Gopherize Me? Great, and if you haven't, check it out. You can build, even though I made that sarcastic comment about being an adult, you can build a cartoon version of yourself, a little gopher. So you should do that, probably. And then please follow me on Twitter. I'm in a battle with my dad, because he doesn't think I can get more followers. So I just want to prove him wrong, frankly. This is how I got here. So that was a good day, wasn't it? But I'm pleased to be here, actually. And also, thank you so much for being able to speak English, because honestly, that's really helpful for me. So this is how I build gigantic scale APIs and things. Well, first of all, actually, you don't really have to do much. It's really a mindset. And I think once you get used to this approach and some of the limitations that you have to work around, you can achieve these things that will scale pretty big. And it's not too difficult. As we know, Go runs extremely quickly. And there are lots of, like Kubernetes is a great example of technology that will actually manage your scale for you as well. And Google App Engine standard environment, which is what I'm going to really be focusing on today, has a similar kind of thing. Although it's a bit different and it's a bit special, and you have to really understand why that is to make the most of it. So I'm going to do a quick what is Go, quick intro to Go, just in case there's anybody who hasn't used it or maybe hasn't seen it. So it's Go. We write it Golang, but we don't say Golang, we say Go. It's a modern programming language. And I'll explain a little bit more why that's important. It's a strongly typed language, so it's not like JavaScript where you can just do anything you like. You can't do anything. Actually, I said once at a talk that you can't do that many things with Go. And it was meant to be a Go talk, and it got a laugh because people thought I was having a go at it, or mocking it. But actually, it's kind of a good point. Go deliberately has this cut down, simplified feature set, which stops. You just can't do complicated things with it. Actually, you can, but it helps you avoid complicated things, which I think is the point. So why do we care about how modern something is then? Because it could just be, it's cool, so we like it, and it's fun, so we use it, and it's just, And actually, that's not insane, right? If you enjoy writing code, if you're enjoying yourself, you're going to do a better job. So that sort of actually isn't an insane reason. But really, the key thing is, if you think about C, when C was designed, we were using computers in actually quite a different way. We had basically single core CPUs, and we weren't really running them not everybody was really running them in the way we do, which is at scale. So when Go came along, they started to think about that, and they actually built into the language things that allow you to really maximize the cores that you have on the machine. And also the networking stuff in the standard library does, it's pretty solid, it's great, and that helps when it comes to building things that can horizontally scale. And one good example of this, of how good the standard library is, was when HTTP 2 came out, Go got it early and got it for free. You didn't really have to do anything, and you could suddenly, things just got better. So Go deliberately doesn't have a load of language things that we're sort of used to. And again, it's really a nice thing in the end. If you feel like you're limited, and you kind of are, but what it means is everything's very clear. There's no magic. There aren't lots of different ways to do things, too many. There's a bit of that. But there's nothing really that you can't build extremely complicated kind of type hierarchies and things. All that stuff that we kind of got used to in other languages, you sort of don't do it in Go anyway, and you avoid the problem. Of course, you can still write terrible code, but we don't. We try not to. And for anyone that hasn't seen it, you probably can already read Go. If you've never seen Go before and you saw that code, anyone, even probably non-programmers, would be able to guess at what's happening there. But it's a C-based language, so it's familiar. So this is how you do structures. You can embed fields here. I've got this greeter structure with a format string inside it. And this is how you do methods. This is a function, and the first, the receiver type at the beginning, that's kind of like puts that method, puts that function on that type. So that's how we encapsulate data. Go also has my favorite implementation of interfaces in the world. This is also my favorite interface still. And it has this kind of duck typing approach, so you don't have to explicitly implement an interface. You can, as long as a type has the right methods, you can use it wherever you need that, wherever it asks for an interface of that type. That's also nice because you can flip it around and actually write interfaces after the fact as well for code that other people have written where they didn't include an interface. It doesn't stop you from having an interface still that matches it. And the other thing is, we format all the Go code so that it all looks the same. And the goal is, when you join a new project, you should be able to become productive pretty quickly. And I think that's kind of the goal. Okay, so if anyone wants to learn more about Go, if you're new, I'm happy to answer any questions you have on Twitter, again, remember, Dad? Because he's having a go at me. Or look at the tour as well, and there's loads of stuff online, but yeah, ping me and I'll get into it. So, I'm going to be talking about Google App Engine, standard environment, and building APIs, that you can be confident are going to be ready to scale, and various little bits and pieces inside that. And I think the first thing you have to think about is in what context is your code going to be running. This is the first thing, and there's a really simple trick, I think, for anybody to get this right. And basically, all you have to do is imagine that your code is going to be running behind a load balancer. So each request, you can't guarantee that subsequent requests are going to hit the same instance of your code. So if you assume that, suddenly it changes the way you might write things. You can't use maps inside the process to store data that you wish to share because it's only in one instance. So it kind of changes the way. And this is even if you think I'm only going to run one instance of this. This helps with design anyway, that assumption. So that's, I'd say, the thing to do. And this interface is your friend. This slide is in every one of my talks that I've ever done. In fact, even if I show my family holiday photos that I've been, right, I still got this in it. I do 20 minutes on it. Granddad's not bothered, but he can shut up, Granddad. So yes, this is, you've probably seen this, but anyone that hasn't, the top thing, the handler, describes just a single method, serve HTTP. And then we have this handler func type here, which is it's another type, but it's based on a function. And then that function implements the method, since it matches, and it just calls itself. So it's kind of like Inception. That's fine. It's like Inception, see? And then that happened. That's like sci-fi. What? Yeah. So this is how I lay out my projects, basically all of them. I build, even if I'm building a tool, like it's going to run as a server, I build it as a package. I have server.go, I have all my roots in one place. Usually in Go, you group by responsibility. So you might have a users.go that's got a user type, maybe some helper methods around users, maybe there's some errors in there, and it all goes in one file. That's kind of how we organize in Go. I break that rule when it comes to the routing, because it's whenever we think about something that we need to look at in code that's API-based, we think, I do, in URLs. And so that's great to just have one place to go to seed all the routes and take it from there. And then you can build a tool that imports the package and runs it. So, and I'll show some examples of that. So I make a server struct, and this has all the dependencies, the shared dependencies for the server. So you might have loggers, database connections, actually, the router, of course. And that's how we are able to decide what code gets run when a certain endpoint is hit, and other dependencies that you might have. And I try and avoid constructors, functions that just create things, because you can't, it can be hiding some magic in there, right? We don't know if the constructor is going to be kicking off Go routines. We don't really know what's being allocated. So I like to just kind of expose the type, and then it's very clear when you use it. But I do break this rule often when it comes to this, because if these dependencies are required, then it just makes it really easy. It's really just about communicating with your team or yourself in the future, not like through time travel, like telling your future self things. There's been no point in that anyway, just write it down. Okay. So yes, all the routes look. So it's obvious what you're going to handle and what code is going to be called. This is where, in Tom's talk on gRPC and Kubernetes, which, by the way, for people, if you're watching this on YouTube in the future, hello. I hope the future's going well. And also, check out Tom's talk, because it's awesome. And he shows a lot of code of like really obvious stuff that you have to do every time, encoding, decoding, the marshalling stuff and things. Well, you can avoid that by popping a method in, popping a function in that does it for you. And so this is the signature. And you can imagine what the body is, but if not, there's lots of examples of this kind of thing online. But notice it's a method on the server, because of course this might want to use some of those dependencies. Same thing for decoding. And if you are building a JSON HTTP API, then maybe this is the whole body. You're just going to create the decoder from the body and just decode it. That's it. But with this little abstraction, you sort of future-proof it a little bit. You maybe in the future you change this without touching any of your handler code. And then the handlers themselves, which are the functions that get called in response to a particular kind of request, with a particular URL and a method usually, they also should be methods on the server. That's how they can access the dependencies. And you don't fiddle around then with the signature. It just stays true to the http handler thing if you care about that, which some people do. This is what I always do, actually. I make it so that it's actually a function that returns a handler. And that allows you to do some kind of per handler setup. So in this case, I'm parsing some files in a template there, and then just because of closures, I can just use that template in the handler that gets returned. This is nice because everything's in one place. It's one function that it builds the dependencies it needs, and that could be doing anything. And it could even be doing expensive things, because this only gets called the first time the instance starts up. You can also take arguments here too, if you have it as a function. So you can see here, handle template, I'm taking a name in, so that returns a handler that's going to handle that. And you can pass in other things too that are maybe other dependencies that are only specific to that particular handler or a few handlers. And you don't want it on the server. And really, this is about storytelling, you know, because you could just stick all the dependencies on the server. But if you do that, it's just not clear where they're going to be used necessarily, whereas this does, you know, makes it very obvious and very clear, and of course, strongly typed. And I think everyone knows by now we don't use context to pass dependencies around. So that's important too. So we get type checks and things. You know, for example, we can't call handle template without giving a name. It's just a compile time error. So, and it's very obvious what this is going to then do. Does anybody put your hands up if you write unit tests when you write code? Okay, now keep your hands up if you write the test code first. Yeah. Honestly, if you haven't tried it, do try it. Sometimes you can't do it. Sometimes you have to, you know, you don't really have it in your head what it's going to be. Although starting to write your tests first helps with that process, because you really start thinking about what am I going to build, what do I need, as a user, what would I want it to be like. You get to have that conversation quite early. And there's help in the standard library for testing servers. So in this code, I create some mock dependency. I'm using the new server helper. Some of the dependencies I'm not going to use in this test, so I can just put them as nil. That's quite nice too, because if you did then use it unexpectedly, you'd get a panic. So you'd see, oh, yeah, I need to either add the dependency here, or maybe I've made a mistake. And then you make a, excuse me, you make a real request using http new request. And you can set headers and bodies and all sorts of things there. And then using the HTTP test package, you make a new recorder. And then I just call serve HTTP on the server, pass in the recorder in the request, and then I can make assertions about what happened when that request was being processed. This is very nice because you're sort of testing really your whole stack. You're testing the routing, because you're making an actual request with a real path. You know, you're testing that the method's correct. You're also testing any middleware that you've got going on. You're sort of testing everything that you do. So it's quite a nice balance, and it remains a unit test. You know, you mock out the dependencies, so there's no, you know, it's not actually going to send any emails. They're mocked out. And I have a tool, for those that don't want to write mocking code, there's a little tool called mock, M-O-Q, which is on my GitHub, which just generates the mocks for you. So you can use that if you like. Yes, so there's some more things about testing. Oh, and this is package as well. It's something I'm trying to, it's a kind of light version of Testify. Testify is kind of quite big, and I think quite daunting now. It does a lot, and is kind of you know, a really simple, cut down, limited kind of version. But it makes writing tests cleaner, like you can see here. I just say it still is equal. You create it and pass in the T, so if it's going to fail, it fails properly. And there's other cool little things like if something fails, if we put some comments here, like http.newRequest there as a comment. If that fails, it goes and grabs the comment and shows you in the failure. So you actually can kind of communicate with yourself as well. I do this. I have an error handler. Since the HTTP handler interface is so easy and simple to implement, I tend to do it a lot, which is kind of the value of single method interfaces. I go on about that all the time as well in other talks if you're interested. But single method interfaces are brilliant for lots of different reasons, and you should look up why, because they're kind of cool. What this one does is it just takes an error and a status, and then it just reports that error. In this case, I'm just using HTTP error, but that could be doing, you know, responding with a JSON error payload or something. This is useful for in the case when you have those handlers and you're doing a lot of the setup in the body of the function before you return the handler. If something goes wrong there isn't really a mechanism to report that. And to make it simple so that you can keep just wrapping methods, you don't want to really return an error. So this is a nice way to do that. You can just, essentially what will happen is, if you hit that endpoint, you just get the error. If that handler was unable to kind of get set up, which of course your tests are going to be checking, right? So it's not just, you're not just deferring it to runtime. You actually would check that. And of course, the server type itself, that structure, should implement the HTTP handler. And often it just defers it to something else, maybe a router or something else. But it just becomes a handler type that you can use wherever HTTP handlers are used, like when you say, I want to handle this path with this handler. You can also do this, and I used to kind of I used to be against this, but it turns out it actually can be quite useful, particularly when it comes to App Engine. You can roll your own handler interface yourself and change what that server HTTP is. Everything else kind of stays the same, but you get to kind of solve really common problems in one place. For example, in App Engine, until very recently, you couldn't use the context that they added to the request. You had to explicitly pass a context around. So then you can do that there. And also, I like to return an error and just have one place that handles kind of just critical, status, internal server errors. And in your handler code, it's nice to be able to just, if error is not nil, return error, or wrap it and return it, something like that. Yes, the downside is that you can't then use these types wherever you use other handlers, and if other packages that you're using are built on HTTP handler, they won't work, because suddenly you've changed the type. You have to kind of build some glue to stick them together, and that's what the glue looks like, kind of. It's just a function, you pass in your handler, and it does the common stuff, and returns a handler here. This return HTTP handler func, that's making use of the fact that HTTP handler is a single method interface and has that handler func counterpart, which you can just use in this way. And you can also make that handler func for your own type as well. And then you get to use that in your own world. And it looks something like this. So this is middleware. This has been talked about quite a bit in Go, but it's a nice little pattern, and it's worth knowing about. So essentially, you have a function, and you pass in a handler, and it returns a new handler, but it kind of wraps the original one. So you can do things before the handler. Then you ask the handler to serve the request, and then you can also do things after. And I kind of love this. And then to use it, you just kind of chain them like this, or you can write different things. You can, because it's HTTP handler, you can pass in the whole server to these middlewares too, or pass in just individual handlers as well. And you can test these quite nicely as well. And the best thing, you can use defer in there. I love defer. Use defer. You can also do some setup, like in the middleware too, right? Because it's just, again, it's a function, and we're going to just return a new thing. You've got some time to do stuff, like maybe there's something expensive that you want to get ready for this, that you need, or you can do it early. So once you have your server, then you need to be able to actually run it. And lots of people, especially when they're new to Go, they say that they feel like they can contribute to a project, but they can't start a project. They feel like that starting something is actually the difficult piece, and I understand that. But this is how you can get started with writing a tool. Now, these do get a bit more complicated. Like, for example, you'd want to take a flag so that you could control the address endpoint. And there's other things you might want to initialize in here and things, but you can save that for later. There's no need to solve every problem. You just want to get something running and up, then just do this. And all we're doing is using listen and serve, and we use our new server that we've made since it supports HTTP Handler. On App Engine, it's a little bit different because you don't really build a tool. You actually push a package, and App Engine's magic runs that for you. So in App Engine, it's not package main, where the tool before, as you'll see, package main. That's because it's going to then be turned into a binary that can be run. In this case, it's any package, and you use the init function instead of the main function. And all you do is HTTP handle, and in this case, I want to handle every possible request that reaches this instance with my server. And on App Engine, that really is enough. I tend not to do much more than that at all. And remember, the router inside the server is with the routes is going to take it from there. So we don't have to list out all our handlers here. We've already done that, and it's already tested in our other package. So there's lots of options for hosting. Once we've built our awesome test-driven API, we then want to put it out in the wild, and there's loads of different options you have now, actually. I'm going to focus on Google App Engine Standard Edition because I kind of love it. It's a bit weird, but I can very quickly build a service, push it there, and it's there, and they just run forever. I've got a few little apps. I have like an idea for like a little startup app, and I'll build it quickly, usually just kind of a bit rough and ready, put it in App Engine, and it's there today still. I've got one that's just been running for years, and basically App Engine, it doesn't cost anything. It doesn't run until requests start coming in. So it's cool. I could go to the website now and you don't notice it. You wouldn't notice that it had to then spin up instances and things. So, Standard Edition, what does this do? Well, it abstracts away the environment, the infrastructure. It abstracts away the infrastructure. This is why you can't use gRPC yet on App Engine Standard Edition, because it doesn't really give you a server that you can then, have persistent connections to. It's abstracted. It's just you give it the code, and App Engine's going to make sure it can run that code for you when the requests come in. So we don't really have as much control. So if you need control, you want to use gRPC, things like that, then App Engine Standard Edition is probably not the right choice. But you can go from 0 to planet scale for free. Not for free, you have to pay, but you don't have to do any work for it. It provides all kinds of things. So it provides the actual managing and running the instances. It gives you data and file storage. It gives you task queues, cron jobs, memcache, monitoring, logging, debugging. It gives you a few things like that. And essentially, this is how you do it. You write your service. You write that little connector piece. You add an app YAML config file. And then you use the gcloud tool after you've downloaded the SDK to deploy it. And it's really simple. And you get things like this. So you get like a dashboard in the Cloud Console. You can see this is Gopherize Me. Gopherize Me lives on there. If everybody in the room right now went on Gopherize Me, I guarantee it would, well, I'm not going to guarantee it, but probably you'll all just hit the site and it'll be there. But if no one's on it at all, there'll be nothing running for Gopherize Me. And it's kind of cool, I think. You also get logging as well, which is actually turns out to be quite good once you dig in. It takes a bit of time to learn it. It's a bit messy. It's a little bit like professional, but it's pretty cool. You can write logs out here. You can see the requests that were made, any errors that happen, kind of reported. It's cool. And it is pretty affordable. You can see this is an example site here. So there's 2.6 million read operations on this, and it's €1.36. The instance's running time is what costs the most, and this is after 10 days, and it's 14 euros. It's kind of cool, and that's actually doing stuff, So Go, because of the nature of Go, it being very quick, there's no runtime, you don't have like a JVM or anything. It's just a single static binary that has everything it needs inside it. It also starts up very quickly. So here's the thing in App Engine, as I said, when no one's been on the site and no instances are running, and the first request comes in, if you use Java or Python, you notice a delay waiting for the first request, and then it happens. And you can ask it to always keep one instance going, just to kind of try and mitigate that. In Go, you cannot notice the delay. I don't notice it. I have to look in the logs to see, did this start a new instance? It tells you in there. But it's kind of cool. This is an example app YAML file. So it's just, you'd say, you're going to use the Go runtime. The service is going to be default. You can have many different services, which are cool because you can sort of scale them out independently. So maybe you've got a user's service that gets hammered all the time for everything. But maybe there's a like forgot password service that you've got that no one forgets their password anymore because computers. That's not right, is it? You can also do handlers at the bottom as well. So actually, I didn't finish explaining that. API version, Go 1. And then the handlers section at the bottom is how you route things to the Go app, basically. So it's kind of just that is all you need. But you can do this. This is very common to have a static folder as well for just things that you want to just serve out. And you can just actually build you can just have free websites hosted using the free quota, and you'll never, if you use Cloudflare to aggressively cache the website, you'll just never see any, you'll never have to pay anything for a website. You can just get a free one. I wrote about it in a blog. The other cool, one of the cool services that are available if you use App Engine is the data store. It's based on Google's Bigtable, and it's got some strange things about it, but it's extremely fast. It's proper Google scale. You get amazing speed, but there's some trade-offs to that, and I'll talk a little bit about that now. Now. So first of all, represent data as a struct. Kind of maybe obvious, but this is what we do. So I'm modeling here a conference. So you need a kind. You need a string that's kind of like a table name, entity name. So the kind is conference, and then I have the fields for the conference. The only weird thing here is I put the key inside this entity, because if I'm going to marshal it to JSON or persist it in some other way, I want it to have an ID. So that's how you can do that. And this little tag at the end tells it not to put this in the data store. We just use a hyphen to say, don't. Keys are a bit weird. It's not like in like Postgres, where you'd have a table that one of the columns is an ID, and that's a primary key. You don't have that. Keys and entities are separate completely. If you get things and put things using the key, then it's strongly consistent, which means I'm going to update my email address, put it, and then I get it immediately, it's going to have that updated email address. If I'm querying, that's not the case. For querying, it's eventually consistent, just because of the nature of the fact that it has to go and update the indexes when you make a change. So there's a kind of, that's the trade-off. It's really optimized for really rapid read, but then you sacrifice a little bit of accuracy because of that. It's just physics, I think. Yes, so you have three options when deciding how to have a key, what key to use. You can just let the data store come up with one for you if you don't care, and that's fine. You should do that probably, I would say, unless you've got a good reason not to. And if you do have a good reason not to, you can use an explicit int or a string. And you might want to do that if you have if say, there's you want the keys to be predictable based on something, like, probably not, but let's say a hash of the email. If you create a user, a hash of their email as the key means that you just have to, when they're trying to sign in, you just have to hash the email and you can get that extremely quickly, rather than having to do a query to try and find a user with that email. And by the way, if they've recently changed their email address, then you might have to wait before that would happen. Do you know what I mean? So there's some good reasons why you might want to explicitly control the key. We don't store the key in the entity body. So even though it's in the struct representing it, it doesn't go into the body. And I explained that earlier. So this is how you put stuff into the data store. You create the object. This is just standard Go. Then you use the data store package from the cloud SDK that comes from Google, it's just free. And you create this, use new incomplete key, let's say. We pass in a context. We're passing in the kind. We use that constant everywhere. And you can have a parent for the key as well. And that's quite significant. I'm not going to go into it now, but it's worth looking at what the ancestor keys, it has some kind of guarantees around consistency that are worth knowing. Then I just call datastore.put, pass in the key and a pointer to the object that I want to put in. And that's it. It's going to give me back another key. If it was an incomplete key, then it's going to give me back what the complete key is now, or an error. Things do go wrong sometimes. And then, after I've put it, I set the key immediately on the object, because usually I'm going to then want to return it or use it somewhere. So, since there's this disconnect between keys and entities, that is something you have to do. You have to manage keys in this way. Getting stuff is as easy. It's actually a bit easier. So, first of all, I decode a key from an ID. A key is actually a struct in data store, but when it gets marshaled, or you can call a method to encode it as a URL-friendly string. So you then have to take that string and turn it back into a key that you can use, and you use decode key for that. And it'll fail if the key's corrupt or something, so if someone's trying to hack by guessing IDs, which is obviously a waste of time, but then you'll sort of catch that. It's not really a security thing, it's just it can't turn it into a key because it doesn't understand what's going on. So then you create a variable to hold your object and call datastore.get, and you pass in the key and a pointer again to the object. And this can be nil because it'll create it for you. And then at the end, after you've got it, remember it doesn't have the key, so I set the key again. So the key thing is a little bit odd, but it's actually in your unit tests, it's worth making sure that IDs, and you're probably going to use the ID to validate, as part of a few different operations. So you do tend to see when that's not working, which is kind of useful. Querying. Querying is also a little bit interesting. Here's some example code that will do it. Essentially, you say datastore.newQuery, again, pass in the kind, and then you can add filters, and you can change the order and do things like that. It's not like SQL. It's quite limited, but extremely fast. But you have to be aware of some of the weird things about it, which I'll talk about. For example, essentially how it works is when you put an entity, it also goes and creates an index of that entity, kind of ordered by every field. And if you do a filter by year and then order by name, you actually need an index to power that. That's how it works. So it's very greedy on storage, but that means it can be extremely fast when retrieving things. But this code will fail if you don't add an index explicitly for year and name. And if I was to order the name the other way, like you can do minus name, then that's another index again. And it's really just because it's kind of cool. That just explains that, I think. Oh, no, some weird stuff. So there's the URL fetch package. You can't just make requests, because it's a controlled sandboxed environment. You have to use URL fetch to create a special client that you can then use, and you get billed for the use of it and things like that. So that's another thing that's worth just knowing. And that's also a good reason why whenever you write any packages that make HTTP requests, you should always let the user specify the client. Because if you don't do that, you wouldn't be able to use it on App Engine. So always let the user give you a client if they want to. Default client maybe, something sensible. And request time is limited. And if you need some help on anything like this, tweet me. Check out Standard Library I/O. That's some friends of mine in London doing training and workshops and things. And they'll do stuff like that. I'm not really trying to promote it, but I just want people to be able to do this and be successful with it. So that's it. I didn't put a thank you slide on, but thank you. I'm done.